Hi, everyone. Oh, how you doing tonight? What? So, wow, what a lot of stories here tonight. You've heard about outer space, you've heard about food, you've heard about economics. I want to take you down into not outer space, but inner space. DNA is one of the most studied molecules on the planet. We've been manipulating it for thousands of years. We figured out the structure almost 60 years ago, and ever since, people have been working to understand its secrets, figure out how it works. Around the world, hundreds of thousands of people every single day go to work on this molecule. And really, I'm one of them. I'm trained in cell biology and genetics, which means I really wasn't a lot of fun at parties. Seriously. And why that was is because it's all intangible, it's invisible. You can't see it. You can't buy it at the store. You can't play with it. You can't give it to your kids. I'm also a microbiologist. Same thing. Although the kids are pretty good at playing with microbes. I was also part of the first wave of people that got into bioinformatics using computers to analyze some of this data. And what I realized right away was, wow, people do connect to computers all the time, everywhere, every day, which is kind of fun. Now I describe myself as a bit as a futurist because I want to connect to people. But here's another thing, you can't see the future either. So really, it's just a mess. What I do know is this, after working in these fields, and literally with the knowledge that is coming out of the community for the last decade, is that the architectures of computing that we're all familiar with have analogs in biology. And in fact, whether something's evolved or engineered, you kind of get to the same place, which is kind of cool. So today I can go to a whole new generation of young people and tell them about these architectures, and they immediately get it. They get it because they've grown up with computers. Computers have always been part of their life. Circuits, modules, free-living computers, networks, we're the same thing. Our brain is the most powerful computer in the world. So cells are just computers. The thing is, they are more sophisticated than any of the computers we have in the world today. That's why it's not obvious. And I could give you a whole bunch of science papers and examples, but the easiest way to convince you of this is just to show you. Because cells can do this. They can self-manufacture. These are E. coli. They double about every 10 minutes. And so you start with one, and you end up with billions overnight. And again, I always like to say, if you just had a cell phone that did that, you'd buy it, and 30 days later, if it divided once per day, you'd have 10 million of them. So DNA is the software that runs this cellular computer. We know it's software. It's digital. Not zeros and ones, ATs, Gs, and Cs, but it's a really different type of software than what we've been used to. It's software that makes its own hardware. What's happening out in the world today of 3D printing, using just your phone, for example, you can scan objects and then manipulate it in a point cloud and then print it on a 3D printer like at my friend's office. These are really big things. It's scan, modify, print, or if you're cool, they call it Rip Mob Fab. DNA is already there, though. DNA, when we sequence it, we're reading it. That's all it is. It's scanning it. We're just scanning what's already there. And we're getting really, really good at it. This is the web page from BGI in China, one of the largest sequencing groups. And they've got a project called 3M, 3 million human genomes. 3 million ecosystem genomes, 3 million plant and animal genomes. We're going to get this deluge of genomic information just from this one site, but there's sites popping up all over the world. They're coming to desktops. This is a desktop DNA sequencer. It costs about $150,000. It's the size of a laser printer. It'll do a human genome in a day. A month after it was announced, this one was announced. It's a USB stick-sized device. See what we're getting to here? And there's analysis programs now that literally are making it easy to understand a genome in a day. It'll analyze it. And we're getting CAD for biology, literally design tools that are pretty much drag and drop, and they still suck. They do. This one's a good one, but they need to get so much more intuitive, and they will. But here's the thing that's really exciting. We're learning how to write it. And right now, it's taking big companies to do it. And we're getting print shops like Kinko's for printing DNA. But we're learning how to write DNA like it was a computer language. So I go around and say, biology is the next IT industry. And I believe it. And there's companies like this that are popping up. This was done by a few grad students in Boston. They got their PhDs at MIT, and then they started this company called Ginkgo Bioworks, and it is literally a biofab. It's just like they print DNA and boot up organisms. And they're just working with bacteria right now, but they're doing some of the coolest stuff ever. And they're all under 30. It's remarkable. So the thing that I scratch my head about almost every day is, why will people line up for an iPad or a phone, and yet still go out and protest with this computer industry? Something's really broken here, and I think we have to fix it. There's so much fear around genomics, and yet we're all genomic creatures. Every living thing is. Yeah, so what do we fear? Every time I give a talk, food, completely upstaged by an 11-year-old. Really, it's... The kid's brilliant. The kid's brilliant, and he's right. Literally, we should be growing food that's clean. Anything that is genetically modified should be labeled so that you have a choice. Some companies, they won't be named, really made it tough for us genetic scientists for about, 20 years. But there's a lot more fears. There's the fear of infection. Every time I give a talk, people go, oh, but isn't that dangerous? Can't I get infected? Won't it? Well, there's microorganisms around us everywhere. We're not used to them. We're not used to thinking about them. There's the privacy issues. These are big ones. DNA is literally your barcode, not just yours, your parents. Peek into your siblings. These are big issues. Who controls it? Another massive area of concern. Who saw this movie? Yeah, if you haven't seen it, Gattaca, go watch it. You need a refresher. It's the whole idea that your genome can be used to discriminate. The whole idea of genetic racism. And this came out in, 1995? The technologies are here and real. We often hear about DNA exonerating a prisoner. You don't hear often of how DNA can also be used to convict. That when DNA evidence is presented in court, it's a fait accompli. You were there, you were involved. But that's not always the case. DNA is complicated. The thing that has surprised me sometimes is people are afraid to get this information. If they get a marker for that they may get Alzheimer's, 20% chance when they're 65 or 70, they're afraid. Every time they forget a phone number, they freak out. Who uses phone numbers anymore? But self-knowledge isn't very useful if you can't start organizing to act on that knowledge. Environmental degradation. Yeah, I think that's a possibility. I think we're doing a pretty good job of it without genetic engineering. Cancer. Ooh, the corruption. Corruption of genomes. This is a big one. 1 in 3 of us get cancer. This is how we fund most of the genetic work. I think it's really important that we understand it, but we shouldn't fear it. And we're making good progress. And probably the biggest one is the whole idea of biowarfare and bioterrorism. Now, since 1972, we basically said pretty much universally, we're not going to use biology for war. It's okay to kill things. We're just not going to go and use biology to kill things. That's wrong. But did this little crazy thought experiment where I thought, well, if you can actually go and kill a cancer cell but not its neighbor, that's like a magic bullet, magic sniper, magic, 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 magic. What if I just wanted to kill your cells and not yours? It's the same tool, but it doesn't even have to discriminate quite as well because you're obviously different genetically. So what does some of these new cancer tools and technologies, these genetic technologies, really mean for protecting high-value targets, presidents, celebrities, etc.? I don't know, but I can tell you this. Most of the scientists that I've ever dealt with don't think about how their tools can be misapplied. Just like the first people in computers didn't think how they were all going to get hacked. I think we have to get up to speed really quickly, because fear isn't going away. That's hard-coded in our genome. We're fearful because it keeps us alive. Seriously. So fear isn't going away. But trust me, genetics is here to stay. It's here to stay, just like computers. This caused me a lot of angst when I realized this, because I really want to get people excited about this stuff. I really do. I want you all to become genetic scientists, or your kids. Make investments, get rich, whatever. Play with the stuff. Buy genetically engineered products you actually want. But I also don't want to have hanging on my consciousness the possibility that someone hearing my story killed 1 billion people. I don't want that. So I had to work through this in my own thinking before I did go out and start telling people, please come to these technologies, learn about them. And I rationalized it because I really think computers, our experience with them, will guide us through this step. Think about the early days of the internet, or the early days of computing. I'm talking way back, like 1972. Back then, computers were mysterious. No one had them, big universities, governments, etc. And when people started getting their hands on it and working with them, the first thing they thought is, oh my God, someone's going to hack into a nuclear missile silo and cause World War III. Well, it didn't happen. They thought, robots, they'll take all our jobs, we'll never work again. Well, the robots get the shitty jobs. And we worried that the robots would come and hunt us down. That hasn't happened yet, but it may in the future. We often predict the future badly. This was a 1950s concept of a home computer. No, I didn't quite get it. What really did happen when things went micro, when they went miniature, when they became democratized, was it just got weird. We got the internet. It literally connected all of us in ways that still freaks us out. It still surprises us. It showed how we're all connected in ways that we didn't even understand before. This is amazing stuff. It's given us new perspectives of our cities, of our world. They're safe for kids, even in the toilet. But it's also brought this idea of omnipresent security. And believe me, we're still going deeper with some of this stuff. Computers are everywhere, and they're going into more things. And there is really cyber warfare going on right now. This is a secret cover of Wired magazine. NSA facility in Utah. I can give you the GPS coordinates. And of course, other groups are learning how to co-opt these systems and do some really interesting things politically here and abroad. So what can we learn from all of this? Whew, I don't know. I'm a futurist, but don't expect miracles. I do know this. Genetic engineering started with things like human insulin that millions of diabetics use. It saves lives everywhere. We're starting to train a whole new generation of kids. There's been 10,000 put through this this program that's global, based out of MIT, and it's amazing what these folks are doing. And it's all open source, and it's moving so quickly. It's really, there's a whole new biotech industry forming, just like there was a whole new computing industry forming when this stuff started to democratize. And you're starting to see it pop up in your neighborhood communities. This is a lab, public lab in New York City and Brooklyn. It's even popping up in a few bedrooms, and this is a licensed lab, I'll have you know. So biotech companies are getting pretty small, and it's really, you're starting to see a new wave of genomics appearing. That's a little different because you're going to be involved in this one. You can be really involved and engaged. They're going to be social. We're starting to see things like this, which are little nanoparticles that you can design using some of these CAD software. This is a cancer-fighting nanoparticle designed with the same tools and technologies, except now we're using DNA as a structural material instead of a programming language. Amazing. And cheap. And we're starting to crowdsource, just like we've learned how you can crowdsource literally satellites that save the planet. We're crowdsourcing cancer treatments by just putting the patients up, and genetic scientists are analyzing the data for free to find not just cancer patients, but kids with rare genetic disorders that have never been identified before. And we're still remembering to have some fun. This is George Church. He just wrote a book and actually wrote it as print, paper, but also in DNA. So he's the most widely published author, 70 billion copies of his book. It's pretty cool. As far as we know, it'll last for 1 billion years. And we're starting to take some of the lessons of biology and genetics to power the next wave of computers. Because we're getting so good at making computer chips that they're getting down to 5, literally, strands of DNA wide. We need the lessons of how biology self-assembles to go and help build our computers now. It's going to be a massive part of the new economy. The government knows this. We're learning it globally. We can't ignore it, and there's lots of people watching and a few more groups coming on board, just like there were in computing. They were slow to the race in computing, but they've learned a few lessons since. So the dark side of DNA, believe me, it's hard to actually talk about it because I'm such an optimist. But the dark side of DNA is really more like the dark matter of DNA. It's how little we know about it today. We're learning so much faster. Millions of people will become involved in this technology in the next few years. But like any technology, the real dark spot is just our intention and our nature of how we intend to use it. And I think we're getting a lot smarter at that if any of the stories here in the room tonight are any guide. So if this stuff scares you now, go towards the fear. You're going to learn a lot of lessons. And believe me, as you get to the front of the pack, understand these technologies, have a voice in these technologies, you'll still be afraid, but you won't be at the back of the pack, because that's an even worse position to be in. Thank you.